Good morning, muchachos. Can I interest you in a entirely impromptu, unscripted ramble about logic? Maybe. Possibly. Let's see. I'm redoing a bit of the ALU, and the bit that I'm redoing is the, what do you call it? The, I guess addressing, mode addressing circuitry. So this ALU, the way I've designed this ALU to work is designed in the loosest possible sense. Is that there is a control word that goes to the ALU individually. It has its own control word, and that control word is 3 bit. I consider them 3 bits because the enable signal I consider to be out of band of the control word, but that's, you know, there's essentially a 3-bit control word that tells the ALU what mode to be in, and then there's the enable signal which tells the ALU, okay, you can now put that onto the data bus. I want you to actually do something in the sense of, you know, have an output. And the way I've done that is I use a 74HC138 3-bit to 8-line decoder, and the 3 bits of the control word go straight into there. In fact, so does the enable signal. So the enable is this outside yellow strand here, and it was actually these chips and the 74HC139 decoders that I use on the register board, so these ones, that set the standard for how I would structure the control word. Oh, I forgot that I've got soup on the hob, so I should go and check that. I'll be right back. I have returned, full of soup and ready to ramble. So, I believe I was talking about the control word that comes into this ALU. There are 5 modes that this ALU supports. The most obvious 3 are the XOR, OR, and then the adder subtractors. Obviously, they have the add and subtract modes. And I've taken the opportunity while I'm doing this to reorder the modes and what they correspond to match the same pattern all over the rest of the Plum, which is that, you know, 0 always starts at the bottom and then 1, 2, 3, 4, 5, you know, works its way up. So add and subtract, adder, subtractor, add sub, they are the first 2 instructions, modes. So mode 0, add, mode 1, subtract, mode 2, and, mode 3, or, mode 4, XOR. And I've currently just got a little bit of test input here at the moment, and it's these 2, so let's give a little bit of space. So they are the numbers, will you be able to see that there? Yeah. 1, 0, 0, 1, 1, 0, 0, 1. And, what was it? Let's have a look. Oh yes, of course. 1, 1, 0, 0, 1, 1, 0, 0. And these are quite handy inputs for this, because all of the different modes of the ALU produce a different bit sequence. So I can easily see when, I can easily correspond what is being output, so what I've selected on the mode, with the actual unit that's performing the calculation. So the thing that inspired me to do this video was because I found myself trying to debug this and looking at this going, what's going on? It doesn't, no, it's not the right answer. Because, and this is what I was doing, I was looking at the add result, this here, and it didn't match up with what I had on what I'd worked out on paper or on the whiteboard. So we do our binary addition, and I will probably make the same mistake I always do. For some reason, when I add 1 and 1, I seem to think the answer... I know that the answer is 2, but I keep writing 3, so hopefully I'll try and avoid doing that. So yeah, 1 and 0 is 1, 0 and 0 is 0, 0 and 1 is 1, 1 and 1 is 2, which is 1, 0, and then 1 and 0 and the carry is 2, which is 1, 0, and then 0 and 0 and the carry is 1, and then 0 and 1 is 1, and then 1 and 1 is 2, which is 1 and 0. So we end up with a carry coming out, and this bit string. And obviously I was looking at this. Let's see if I can... is that going to be the right... Well, I suppose the number is symmetrical, so... yeah, no, that's the way I should hold it for you, because this is the least significant bit over on this side. So we can see that the result that I'm getting is not the result that I calculated. And so obviously the first place my head went was, Daniel, you suck at maths. You know, work it out again, try it again, what's going on, is there a dodgy connection, you know. I assumed that I was wrong. And I kind of was, but I also wasn't, because this is correct. So 1001101 and 11001100 does make 011000101. But obviously I'm getting 1110010, which is, so that the first, the upper nibble's correct, 0110, 0110, but the lower nibble is supposed to be 0101, but actually it's 0110. So what's going on there? Why is it off by 1? Now notice I say off by 1. This is a classic programmer's mistake, always, and it takes different forms, but the same pattern is realised over and over and over again. Off by 1 errors. And where's that coming from here? Because, yeah, that is correct, and I've definitely, you know, I'll double check up here. We can see this. Everything, all the input bits on both sides, they're all pulled low, so they're all 0 unless they've got a wire in place, and we've got 100111101, and we've got 11001100. So what's going on? Where did I get the extra 1 for? From? Well, what was I actually trying to achieve when I started rejigging all this? Carry input. So that I could save the carry flag and feed it into the next addition. So, actually, it's this. It's the carry flag. So this is essentially the carry flag at the moment, and I've just hardwired it to 1, to true. A little bit difficult to see because the thing is rubbing off on these breadboards. I've had this assembled for quite some time now, and I'm starting to... It's getting ever so slightly flakier, so I'm a little bit concerned that the contacts are starting to wear, but you know what? Worst case scenario, I'll just bend some more wire and build another one, so screw it. So if I take this carry, which is currently 1, so notice it's our answer. If we just plus 1, well then, 1 0 1 1 0 0 1 1 0. So it's the answer we're expecting, +1. And there you go, there's the carry. So if I take the carry flag and clear it, essentially, clear the carry flag, we have a new answer. Which is exactly the first one that I was expecting to get. 011000101, 011000101. So it works. Hooray!